Okay, so today we're in section 4.2. If you were 8th graders, not 8th graders, but if you were in the standard pre-algebra class, okay, these two sections, 4.1 and 4.2, after these sections, like in standard algebra 1 or when you go to algebra 1 next year, they're together, okay, adding, subtracting, multiplying, dividing. But while we're building foundation, they're separate, okay? So what am I saying? I'm saying that you're going to see a lot of similarities here between 4.1 and 4.2, all right? They can pretty easily be sections together, all right? So the first slide looks pretty similar to the first slide in 4.1. Equations have how many solutions? One solution, okay? That makes it true. So there's only one value that can make an equation true. I think we would all agree that we could probably do this one in our head, right? 5 times what equals 15? 3, right? Okay. But I'm still going to use, in all of these questions, and you'll even see some today that aren't that simple, that you could just do it in your head, okay? So there is another method that works every time. Even when I can't visualize the answer to start, I can follow my strategy of using opposite operations to solve equations. It's so important, guys. So even when I walk around checking your classwork today, I'm not just checking for the right answer. I'm checking for your work. Because if you have the steps and if you're practicing the steps, and I know this is where some of you guys are like, oh, I have to show my work. I don't want to show my work. I know the answer though, Miss Kinder. I understand that. But you have to trust me, and you can even just flip ahead a couple pages in your books, and you'll see why, okay? Because the equations, there are only a very select few that you can solve without showing inverse operations. So what is your goal? Your goal is to get the variable by itself. Are there any blanks here? A few, okay? On one side of the equation. All right, this is important. I know it's the last point, and you think, oh, the last point is not very important. You're going to hear me say reciprocal a lot in today's lesson. So what is reciprocal? It's a flipped fraction. So take any fraction. All right, I want you to write down this fraction, 2/3. Okay? In order to get the variable by itself, sometimes you have a fraction connected to it. So how can you get a fraction to reduce down to 1? You can take the original fraction and flip it and multiply, and this is what we call the reciprocal, the inverse, okay? And what happens now is I cross-reduce everything down to 1, and that's what I want. That's what I want, is for everything to reduce down to 1. I can do that using reciprocals. Out of all the concepts, you'll see fractions the most in this lesson, okay? So I wish there were more whole numbers, but we got to do fractions and decimals too. But I have good news. Doesn't help you as much on fractions, but we're bringing calculators into the picture in chapter 4, okay? So you can use calculators, and here's why. All right, in chapters 1, 2, and 3, like I said, it's the warm-up for the game, right? I'm making sure that you have those foundational skills, okay? And while those are still important, in chapter 4, I'm teaching you how to solve an equation, not how to divide decimals, right? We've already kind of done that. And we're still going to continue to do that without our calculators and keep those skills sharp. But to get through these lessons with decimals and fractions, we need to cut down on some of that work. And remember, okay, guys, don't worry, just do it off to the side. How many times have I said that? Okay, so now we'll just use our calculators for that step, okay? That's okay. I think what you're going to find is you still use mental math a lot, all right, because it's faster, honestly. Okay, so here's the first question we always ask ourselves. What operation connects my number and my variable together? What operation connects them? What do we see here? Division. We see division. What is the opposite of division? Multiplication. So what I must do to get x by itself, to get this number out of the fraction, I must multiply by its reciprocal. Okay? So now they can cross-cancel. And I'm allowed to do that as long as I do it to the other side. I'm allowed to do that. I'm not changing any values as long as I do the exact same thing to the other side. Okay? So that's my rule. Why did I do all that? Because I want to get x by itself. Because if I get x by itself, then I will know what it equals. Okay? Okay, so what's my answer? Now I just bring down what's left. X equals, what's negative 6 times 3? Negative 18. Negative 6 times 3 is negative 18. All right, now we can check our answer. We can check it. Okay, we can check it by plugging it back into the original fraction, the original equation for x. Okay, your homework is going to call for checking. I want you to check on a quiz or a test. I'm not going to take off points if you don't check. But this is a way, guys, on your equations test, you literally, and this is a great thing. It's a beautiful thing, really. You can turn it in and know that you got a perfect score. Not just think, I think I did great. You can know that you got a perfect score because you can check all of your equations. You can check all of your answers. When you plug in negative 18 for x and you divide it by 3, does that equal negative 6?
Yes.
It does. Because they equal out, because that's a true statement, I know I got the right answer. Okay, so this isn't my answer. This is my double checking my answer. Negative 18 is my answer. Okay. All right, I want you to try the second one. Don't just tell me the answer. You say, Ms. Kinder, I know the answer. I hope you know the answer. Okay, but we're practicing the steps. All right, so we're starting basic so we can practice steps. And that gets us into the more difficult concepts. All right, so multiply both sides by 5. You guys did great on this. Multiply by 5. X equals 10. Perfect. You can plug it back in and you can check. Okay, so now let's look at these next ones. These look a little different. What looks a little weird about the first one? Just tell me. What looks weird? The A is negative and there's no number. Okay, but we know that it has an understood what? 1 in front of it. So now we need to identify what is the operation connecting my number and my variable here. When there's nothing in between.
Multiplication.
Yes, it's multiplication. What's the opposite of multiplication? Division. So you divide both sides, and hear me on this. This is important. By whatever is connected to your variable, even if it's negative. You have to take the negative with it. You can't leave it with the variable. So divide both sides by negative 1. And what's negative 24? Remember your rules. Divided by negative 1. Just tell me.
24.
Positive, yes. 24. Okay, it's positive 24 because there's an even number of negatives. All right, let's look at this next one. What's different about the next one?
Decimal.
It's got a decimal. It's got a negative.
The answer has
What do you notice about the order?
It's flipped around.
Yes, I would say backwards, right? Because the X comes after the equal sign, okay? And that tends to mess people up because they're in the habit of looking at the left side to solve. But here's why this example is in here. Because it does not matter what side X is on, that's the side I have to focus on, okay? So what is connected to X? Here. Multiplication and what number? Negative 4.5. So that's the value that I must divide by. I have to divide by negative 4.5. So in our brains we think, oh, I need to divide by 18 because it came first. But that's not my rule. My rule says I must eliminate whatever is connected to my variable. So if my variable comes second, that's okay. I still look at that side first. So now we know that, okay, I'm just going to remind you. If I divide any number by itself, it reduces to 1. What's 5 divided by 5? 1. What's 10 divided by 10? 1. So negative 4.5 divided by negative 4.5? 1. Okay? So they don't cancel to 0. They cancel down to 1. I can do this as long as I do the exact same thing to the other side. All right, so here's one of the rare instances where your calculator could save you a little bit of time. All right, in chapter 3, I would have told you to do this long division. Okay, you can punch it in your calculator real quick. 18 divided by 4.5. Oh, negative. But don't put the negative, don't put the negative in your calculator because you're going to get confused and someone's going to make it subtraction and get it wrong. Just know, is your answer positive or negative? Negative. So now divide your numbers, okay? Divide the numbers. Why are y'all packing up? Okay? All right, so 18 divided by 4.5 is what?
4.
It's negative 4. X equals negative 4. Or you could say negative 4 equals X. Either one is the same way. Okay? Same answer. X equals negative 4. Okay? All right, so now we have fractions. We have fractions connected to variables. But what I want you to notice is this, okay? I don't want you to write anything yet. Okay, so just everybody look up here. I'm going to show you what's happening, but then we're going to cut out a whole lot of work to show. Can I get an amen? Okay? All right, very good. Okay, so if we don't have to show like 2 or 3 steps, that would be really nice. But you need to understand why we're doing it. And that's what I'm going to show you. Okay? So I have a fraction, and what operation connects that fraction and variable together? Multiplication. So everybody agreed this is 4/5 times x. Okay? So because it's multiplication, I need to divide by whatever is connected to x. Don't write this down. Don't write this down. Don't write it down. Okay? So this becomes a complex fraction. Do you guys remember those from chapter 2?
No clue.
Okay? And what I told you to do, basically, this is a fraction being divided by another fraction. Okay? But does anybody remember my rule for dividing fractions? KFC, right? So what you're telling me is if I divide by a fraction, I'm actually multiplying by the reciprocal. Okay? I'm flipping that second fraction and multiplying by the reciprocal. So instead of showing, guys, dividing by a fraction here and dividing fractions side by side, why not just multiply by the reciprocal to get it to cancel? Okay? So that's what we're going to do. I'm going to erase all this. Okay? You need to understand, though, I'm still following, okay? So if I lost you on that, just listen to this. I'm still following my rules for inverse operations. Even though that's multiplication and I'm also multiplying, I'm actually dividing. But then I have to, flip the fraction. So, multiply by the reciprocal. And now look, guys, everything cross cancels. So that's what I wanted, for x to be by itself. And I can do that as long as I do the same thing to the other side. Multiply the other side by the reciprocal, 5/4. Okay? So, in my opinion, you don't need a calculator for this. All right? Can I cross reduce anything?
Yes. The 4 and the 8.
The 4 and the 8. Make sure 8 stays negative. What's negative 2 times 5? Negative 10.
Negative 10.
All right, so you see, guys, already I have an equation that would have been really difficult to solve without inverse operations. Okay? But now that I have inverse operations, I'm just following steps and I get to my answer. Okay? What do you notice about the next equation that I'm solving? You have a negative fraction and it's improper. Okay? So my rule is still the same. Okay? This technically is, yes, multiplication, but I know if I divided a fraction, I'm actually just flipping it and multiplying. Okay? So what would be the reciprocal of negative 3/2? What would be the reciprocal, Hadley? Negative 2/3. So all I do is I multiply. And again, guys, I know I just said this, but if it's negative, I have to keep the negative with the number. So everything cancels out exactly, and I take the negative to the other side. Okay? So now I bring down my z, Just put a little line to make it look more like a Z, I guess. All right. But is my answer negative 6? No, because what do I need to do? Yes, you have to do it to the other side. Okay? So now I have to do negative 6 over 1 times negative 2 over 3. All right, go ahead and finish that one. All right, Jack, what'd you get for your answer?
4.
Yes, Z equals 4. Now, you could cross-reduce this to negative 2, and negative 2 times negative 2 is positive 4. Did anybody else get 4? Anybody else get 4? Okay. All right, very good. We're going to do one more of these. Okay, we're going to do one more of these. I want you to answer this one and compare your answers with your neighbors. I'm just going to walk around for a couple minutes and just kind of check on you guys. All right, go ahead and solve this next one. Okay, so what did I multiply both sides by?
5 over 8.
Negative 5 over 8. Everything cross reduces. Multiply this side by negative 5 over 8. And B equals negative 25 over 8. Okay, or B equals negative 3 1/8. Either answer is acceptable, neither one is a deduction. Okay, now if you had an answer that could be reduced, I would look for it to be reduced. Okay, like 6 over 4, reduce that to 3 over 2, something like that. All right, guys, quiet. Okay, this challenge question, we are going to talk about this challenge question tomorrow. On the half day, but listen, here's what it's asking, so this will at least be in the recording. Okay, asking whether or not they are equivalent. I want to know if they have the same answer. If they have the same answer, they're equivalent. So how can I find out if they have the same answer? You do the problems, you solve them. So all we would do in this problem or in this question is solve each one. If they have the same answer, they're equivalent. Okay? All right, let's talk about inverse operations again. And truthfully, I almost wonder, and I'd have to look back, but I almost think that this should have been at the beginning of the lesson, because this is just what we were talking about at the beginning. Just give me the opposite, and you guys can just say them with me. What is the opposite of subtracting 12? Adding 12. Okay, what's the opposite of multiplying by 9?
Dividing by 9.
Dividing by 9. Okay, what's the opposite of adding 6?
Subtracting.
Okay, everybody, guys. What's the opposite of subtracting 10?
Adding 10.
Adding 10. All right, so it's just literally, it's just trying to drive home that point of inverse operations. We will do the most complex and complicated equations, and it comes down to that concept. If you understand inverse operations and those steps, you should be able to solve even the most complicated ones. All right, modeling real life. We cannot understand this problem, and there's a typo in it, without looking at, in our books, at the problem, because there's a thermometer in here that we need to look at to be able to solve. Okay, so go ahead and turn in your books to page 136. Okay, so when we're reading the example from the book, yes, the temperature is decreasing 4.5 degrees each hour, but the question is, when will the temperature be 32 degrees Fahrenheit, not 29? Okay, so that's supposed to be 32 degrees Fahrenheit. Okay, so what we are trying to figure out is, what is the change in temperature? Okay, so I'm looking for the change in temperature, which means I have to know the starting point. Okay, so where did it start? What temperature? According to the thermometer.
56.
Not the thermometer. What is that thing called? It's the temperature gauge. Okay, we'll just call it that. I don't know why I just said. I'm thinking like fevers. Okay, sorry guys, my brain's fried. All right, so okay, so it has changed 24 degrees. In which direction? It went from 56 to 32. So did it go up or down?
Down.
It went down, okay? So my change is negative 24 degrees. That's how much it's changed. And Okay, so here's the tough part. What operation is going to connect my value and my variable together? All right, so here's my advice to you. There's two different things that can help you figure out what operation is here, okay? The first one is if there is a repetitive value, okay? So let me just kind of back up for a second. What if I said 2 plus 2 plus 2 plus 2, right? That's, if I have a repetitive number being added, I can multiply it by how many times it's repeating. Does everybody agree? It would be 8, and 2 times 4 is 8. So when I see that temperature is decreasing by the same amount each hour, the same exact amount, I know that I can multiply that by the number of hours. So if it's -3 over 3 hours, that's -9, okay? That repetition. Stop looking at that clock. Okay, all right, so it's decreasing 4.5 degrees every hour. All right, decreasing 4.5 degrees every hour, and now I just follow inverse operations. Okay, because it's a decrease, it's negative, divide by the negative value. Okay, and that will tell me how many hours it's going to take. Okay, well, that's fun. What's 24 divided by 4.5? Yeah. 5.3 repeating. Okay? All right? But that's not the answer to the question. It says when. It says what time. It says what time. Okay? So, what time? All right, it says midnight. All right, so the starting time is midnight. All right, so what's 5 hours after midnight?
5 o'clock.
5 a.m. And now what is about, okay, so we're just going to round. What is about 1/3 of an hour? Look up at the clock.
20 minutes.
20 minutes. Okay, so 1/3 of an hour. So what's half of an hour? 30 minutes, right? So we just can cut that hour into 3 sections, divide an hour by 3, 60 minutes by 3, and get 20 minutes. So it's going to be about 5:20 a.m. Okay? Now, if parts of that went over your head, it's okay. All right? This is not the focal point of this lesson. If you can solve the equations. Are we there on the equations? Yes. Sort of? Okay, if you're there, that's where I need you to be for today. Your test is not tomorrow. Your test is in 2 weeks. Okay? All right, we have plenty of time. Okay, but while I still have the recording going, I'm going to help you guys a little bit with your homework. Okay? Just a few clarifications here on your homework. The first couple questions are just solving the equation. Okay? So you should have the tools you need to solve that. Number 28, you're finding the error. Okay? Number 32, you are going to write an equation on number 32. How are you going to know the operation? There should be a key word, right? Okay? So, if it's division, at the off chance that it's division on number 32, by chance, you need to make it a fraction. Okay? Make it a fraction and it'll be easier to solve it. All right, so that's your hint on number 32. Look at number 34. Oh, gotta love number 34. Okay? A rock climber averages 12 3/5 feet climbed per minute. How many feet does a rock climber climb in 30 minutes? If they're climbing, and I'm going to give you another random example. If I say I climb 6 feet per minute for 10 minutes, how far did I climb? What did you do to find that answer? You multiplied. So I'm about to flip it on you though. If you have to multiply to get your answer, that means you have to have division in your equation. Yes. If you have to multiply, you just told me I need to multiply, right? To get your answer, then that means you have to have the opposite operation in your equation. Yes. Okay? So, basically what I'm saying is how many... All right, I'm helping you out on number 34 because, again, we're not there yet. That's why you're giving me strange looks. You will get it, though, I promise. you figure out what operation am I doing. You just said I need to multiply to find my answer, which means I need division. How many minutes, or how many feet, I mean. So I'll use F for feet to make it make a little more sense. Divided by 30 minutes, okay, would equal my feet per minute, which is 12 3/5. Okay? Which is 12 3/5. There's another way you can solve this, okay? This is almost writing it the complicated way, but to stick with writing equations, this is what we're going to do. You say, I couldn't have come up with that by myself. That's okay. We're not there yet, but now you can solve the equation, okay? Number 35, this is the other one. All right, and the bell's about to ring. You need to come up with an equation. Hold on, just 2 seconds. Not 2 seconds, 30 seconds, okay? That equals -3. So I'm going to give you a different one. 2, okay? I don't care if it's multiplication or division. I only need one equation where the answer would be what they're asking for. So here's an example of that. 2x equals 4. Do you guys agree my answer would be 2? Yeah. My answer would be x equals 2. Okay, so on number 35, it wants you to give me an equation where my answer is -3. Here's what I don't want to see. I don't want to see 19 of the same equations tomorrow because you all just helped each other out. Okay, so it's fine to work together, but you need to come up with your own equation. You understand? Okay, and I just gave you an example, hopefully that would help you. All right, you guys have a great afternoon.